So on Thursday, we were looking to find a certain delta for the epsilon value of 1, if we were given an epsilon value of 1. So the way that we did that was we started with the epsilon absolute value of the equation, which is the f of x minus 2 less than 1. When you have the absolute value, you make one positive, keep one positive and make it negative. That's going to determine our epsilons. Then we just solve for x. So once we solved it, we got to a certain point where we ended up with, over here, our delta, which was x minus, absolute value of x minus 5, because that's our x naught. That's what plugs into this equation here for the x minus, for our delta, oops. So whenever we were trying to find our delta, the formula for that is x minus x naught, and it's the absolute value of that. It's less than delta, which is greater than 0. We plugged our x naught of 5 in, which came from here. Then we didn't know any of this. So what we actually did was we went down through this problem for the epsilon, knowing that we were setting our epsilon equal to 1, and we solved it. We ended up with x minus 1 is less than 9 is less than 1. Add the 1 to all three to get x by itself. And we got x had to be between 2 and 10. So that's our interval. So then we had to figure out which one is closer to 5. So which one is closer to 5? 2 is closer to 5 than 10 is, which is how we determined our delta of 3. Because our distance between 2 and 5 is 3. So then we plug that back in up here to show that we found what our delta actually is. All right, I'm going to give you guys some time. I want you to try to do this one on your own, number 31 here. We're starting with our formulas are given to us. X minus absolute value of x minus x naught is less than delta. And we're starting with f of x minus L has to be less than epsilon. So at this point, we're just plugging our numbers in and see if you can find your answer here. So when we start, we have to start by plugging our values in. We don't know what delta is. That's what we're actually trying to find. So it's 0 is less than the absolute value of x minus x naught. What's x naught? Three less than delta. We don't know what delta is. Let's move on to the next part. What's f of x? Three minus 2x. What's L? Our limit. Now that's our epsilon now. So now we need to find our limit in order to plug it in. How do we find our limit? Well, we take the limit, it's x approaches 3 of 3 minus 2x. Is there anything restricting me just throwing this 3 in here? No. Since I'm not won't make me divide by 0 or give me the square root of a negative, I can just throw my 3 right into the problem. 3 minus 2 times 3, which is negative 3. So my limit is negative 3. It's f of x minus the limit, so it's f of x minus negative 3. Put your absolute value sign. My epsilon, you already told me, is 0.02. Now I'm going to solve this right side here. So in order to do that, I get rid of my absolute values first and make it negative 0.02 and then 0.02. Now before I move on, 3 minus negative 3 gives me positive 6. So this is negative 2x plus 6. Now I solve for x. Subtract 6 from everywhere. This gives me negative 6.02. Over here, this gives me negative 5.98. Divide by a negative 2. I'm left with x in the middle. When I divide by a negative, it means that my direction of my inequality changes. This becomes 3.01. And then negative 5.98 divided by negative 2. Again, my direction of my inequality changes. It becomes greater than. And then I divide that out, and that's going to give me 2.99. Now we take these two answers, which means that I have a range of values between 2.99 and 3.01. I'll bring it up here. Whichever one is closest to 3. In this case, they're both 0.01 away from 3. So if I just plug those values in, 2.99 minus 3, my absolute value here gives me 0.01, because this would be negative 0.01. Absolute value makes it positive. That's my delta. If I plug 3.01 in, I get the same thing. If I had got another number here like 0.03, I'd go with the smaller of the two. That becomes my delta. So now to finish the equation out, it is 0 less than the absolute value of x minus 3, make that bigger, is less than 0.01. In other words, if I wanted to get within 0.02 of my function for my y value, then my x would have to be within 0.01 of 3. This here is my final answer. Or you could say delta equals 0.01. That works too. Prove that the limit as x approaches 2 of f of x equals 4 if f of x equals x squared when x is not equal to 2, and 1 when x equals 2. So I'm going to head down the same path here. I'm going to start by setting up my delta equation. 0 is less than the absolute value of x minus x naught, which is 2, which is less than delta. Then I need to do my absolute value of f of x minus L. In this case, my limit is 4 because it tells me that the limit of f of x is 4. And then here they don't give us an epsilon, so we have to leave it as epsilon. So now, since we're looking at the limit as x approaches 2, I'm going to use the top equation because I'm not wanting to know what it is when x equals 2. I'm looking for when it approaches 2. So that's what's going to plug in for my f of x. X squared minus 4 is less than epsilon. Now treat it the same way, except that I'm still going to have a variable here, which is more helpful to me in all actual terms, because I don't necessarily want to know exactly what it needs to be when epsilon is a certain number. I'm looking for when it's a general statement. So if I am given any epsilon, I could plug that epsilon in that I wanted to an equation. This works a lot in when you're manufacturing something, you'll be given certain tolerances. Like if you make a pencil, the pencil length has to be between, say, 5.98 inches and 6.02 inches. If it's anywhere outside of that range, then it's going to be a rejected pencil. It's not going to be counted. So it won't be sent out to the consumer. So when you're looking at that, a lot of times you're going to have to adjust the machine in some type of way so that the pencil length gets cut off at a certain length. It's not going to be like, oh, I can just set it to be 6 inches. It'll be the turn of a dial or something where I'm turning the dial a quarter of a turn or an eighth of a turn based off of that. So that would be my delta, which affects my epsilon, which is the length of the pencil. Not all pencils are the same length, even as I manufacture them. My epsilon would adjust based on what I have. Like if you go mini golfing, those pencils are extremely small. But I still should be able to find my tolerances based on different epsilons, which is what we're getting at here. I still set it up the same way. I get rid of my absolute value. This becomes negative epsilon is less than x squared minus 4, which is less than epsilon. Solve my equation. X squared minus 4, I add 4 in all the different places. This is going to become epsilon plus 4. This is negative epsilon plus 4. And that's still x squared. Now I have to take the square root in order to get rid of the squared. So this gives me the square root of negative epsilon plus 4 is less than x, which is less than the square root of epsilon plus 4. So this tells us that our inequality holds true where f of x, absolute value of f of x minus 4 is less than epsilon for every value within the range of square root of negative epsilon to epsilon. Okay? So now we need to find a delta so that when I do 2 minus delta and 2 plus delta on either side, it's got to be within this interval. So we would take the minimum of those two. In this case, we don't know what it is. And that would be based on what we find our epsilon to be in order to make it true. So this is our final solution here, because we found what our x is, and now our epsilon, or our delta here, would depend on whichever one of these is smaller. Questions? This is going to start our homework. And I'm just going to give you some examples of what this looks like. So for number 1, if this is 1 through 6, it's going to say sketch the interval AB on the x-axis with the point x0 inside, then find the value of delta greater than 0, such that for all x, 0 is less than x minus x0, and the absolute value less than delta, so that I can come up with A is less than X is less than B. So all I'm doing is setting up. You could do it a number line. You could do it any way you want. I just need to find a delta. This is assuming my lower bound is A and my upper bound is B. Okay? So if I'm looking at a number line even, looking at this number line, I could put these points on a number line. There's 0. There's 1. We'll call this 5. And call this 7. So my interval has to fall within 1 to 7, because that's what it tells me. Those are my endpoints. So what would I set my delta at so that I would include all the values? So this is like I'm coming down to the end of my problem here, going back to say this example. I'm coming down to my end of my problem here, and I have it between two values. When I look at my delta then, I'm looking within this interval and whichever endpoint is closer. 7 is closer to 5 than 1 is. The difference between 7 and 5, or the distance between 7 and 5, is 2. That gives me my delta. X minus 5 has to be less than 2. So that now by setting that delta point, I'm restricting my interval so that instead of being from 1 to 7, it's going to be from 3 to 7, because as we learned on Thursday, it has to be the same distance for the x's away from our x0. I can't go 4 in one direction and 2 in the other direction. If I'm going 2 to the right, I have to go 2 to the left from our x0 in order to include all my points. So that's what 1 through 6 are like. Seven through 14, we're going to use the graphs to find a delta greater than 0, such that for all x, same as we've been doing. So if I'm looking for an epsilon between 0.2 away, then it falls between, so this is 0.2 away from 6, our limit. So f of x minus our limit 6 has to be less than 0.2. So if I'm looking for a difference between of 0.2 from our limit of 6, that can be 0.2 above or 0.2 below. Following our chart here, if this is my graph, in order to hit 0.2 below, or here, I need to come up from 4.9. So in order to find an epsilon of 0.2 on the lower side, it has to be 0.1 away from 5, or from x0. To hit the high point of 6.2, coming from this direction, to hit the high point of 6.2, my x would have to be 5.1, which means that I'm 0.1 away again. So when I look at this now, in order to get in between here, I had to be 0.1 above and 0.1 below. So 0.1 above, 0.1 below, in order for my y's to match up 0.2 away. So that tells me my delta equals 0.1. delta equals 0.1, and you can either leave it like that, or it's better if you plug it in. X minus 5 is less than 0.1. For this one, kind of the same thing. I'm looking at 9/16 to 1 in order to get to the lowest one, which is 1/4 away from 1. To hit the high point, which is 1/4 above 1, I would have to hit it 25/16. Now I need to find the lower distance of the two. If I look at this, you can see which is the lower distance of the two, but I have to actually do the math. So 1 minus 9/16, 1 is the same as 16 over 16. So 16 minus 9, this is a distance of 7/16. 25 minus 16 is a distance of 9/16. You go with the lower, so it would be 0 is less than x minus 1, and it's the lower distance, 7/16. Yep, 7/16. So my delta would equal 7/16. All right, you're getting a homework assignment on this.